Okay. As we know, aquaculture is the world's fastest growing food production sector. Aquaculture contribution to global fish production has continued to rise, reach about 49% of the estimated of 178 million tons of global production. Furthermore, the share of aquaculture production out of the global fish production is expected to grow from 48% to reach in 2020 to reach about 53% in the 2030 and 140 in 2050. The most urgent concern in the whether the sector is growing sustainably and fast enough to meet the future projected demand. Furthermore, accelerated by the rapidly growing human population and reducing the environmental impact with the expected adaptation to climatic change. Aquaculture production is often at a risk between the environment as a combination between the environmental concern, including resource decline, habitat destruction, eutrophication, biotic depletion, ecological effect, fish diseases is expected to increase, and greenhouse emission. On the other hand, we are expected climatic change impact, this is including cyclone, drought of the land, flood, growing global warming, ocean acidification, rainfall variation, and salinity, especially for the surface of ocean, and the effect on the freshwater sources and sea level rise. This impact on the aquaculture production is especially for nursing, rearing, and grow out reproduction phases. This we are expected to effect of stocking density of fish facing on the shipper high mortality, and also effect to the feeding behavior that will be changed. And at the end of this, we are expected to getting low growth for the fish. We have two different effects of the climatic change on the aquaculture production, is indirect and direct. Indirect climatic change is affected by related to change on the behavior strategy of fish, such as the change of feeding behavior, feeding behavior also, and on the other hand, to effect on the physiological comprehension. This is including metabolism. If the temperature increasing, we expected this effect on the metabolism for the fish as a blooded animal. On the other hand, the direct effect, the indirect effect is effect on the ecosystem. The ecosystem, we will expect it to altering the primary and secondary productivity, and also effect on the input supply, increasing the diseases, increasing the beats for the aquatic animal. At the end of this, the aquaculture production will be affected by quality and quantity, and also the prices. This is effect on the market and the prices of the market. At the end of this indirect effect is effect on the aquaculture livelihood for farmer and the feed security and nutrition. Therefore, if we consider the aquaculture greenhouse emission in this sector as animal production, we greenhouse emission in the C2 through the normal respiration of the aquatic animal, but this is the low amount. The aquafeed are considered the large source for greenhouse emission, including the processing, during the processing and transportation of the raw material, energy used during the processing of feed, and the very important issues is high feed conversion ratio. These are very important for the CO2 emission in this sector. But as Dr. Rihanna said, there is still a gap for exciting knowledge regarding the pathway and contribution of the aquaculture production to global greenhouse emission. So one of the amazing way, and you must be used, we need to use the blue-green water by reducing water footprint and increasing the efficiency of blue-green water to increase the fish production using sustainable intensification of freshwater aquaculture. We need increasing coastal aquaculture and mangrove restoration. They are very important. Mangrove considered as blue carbon stores. Also, expansion of mariculture. This figure concluded the problem and the solution. You can the red color is what is the constraint in the if we need to increase the future production in the future for production. This including the environmental constraints, as we are said. Also, the impact of climate change with competition for the resources. We need more fish fry, we need more feed, and also we need more land. We are expected 25% from the total land will be drought from in 2050. Also, we need more fresh water by 2050. This is a very problem for the world problem in the we don't have now many of source for fresh water sources. Also, we expected the population growth will be reach 8.5 billion. Therefore, if we need to increase the production, and we need the during if we need increasing the aquaculture production with environmentally sustainability and climatic change availability, we need to change our system to use integrated aquaculture, recirculation aquaculture system, and seafood aquaculture. Integrated aquaculture including rice fish farming, pond-based integrated aquaculture, agriculture, mangrove shrimp culture, and integrated multi-trophic aquaculture as aquaculture system. For recirculation aquaculture, this is very expensive, but we need to use in the future. We will need this system, but we can use biofiltration to reduce the cost of institution and the operation, and also aquaponics. For the seafood culture, we need to expansion of coastal aquaculture, expansion of mariculture, molluscus, and seaweed farming. We are presented case study. This case study is depending on the hortimade aquaculture, hortimade project towards circular horticulture, closing the loop of Mediterranean green houses. This project is part of BREMA program and support by European Union. Our coordinator, I think Nora, coordinator, is attended our meeting from UNCWA Systems. And we as NIOF as Egypt, and Biskra University from Algeria, and Desto from Spain. The aim of this project is to evaluate the feasibility of combining the integrated multi-trophic aquaculture using for production of different aquatic species with horticulture production using hydroponic system, floating graft system, and nutrient film technique, to produce different aquatic and horticulture to maximize nutrient releasing resulting from the culture of plant and aquatic animal. There are other objectives such as we are test user-friendly and flexible decision support system allowing to smart nutrient irrigation, climatic control, and integrated pest management for greenhouses. Also, we are testing the efficient and cost-effective partial and full automation for greenhouse as a model for adaptation for climatic change. This project is depending on the idea. The idea is that about 20% from dietary nitrogen and 25% from the phosphorus nitrogen were deposited for the fish, and the remaining amount of the total feed is released to the culture media as a water. As a solid waste, this is unfeed fish and the faces and soluble waste from nutrient, nitrogen, phosphorus, potassium. Therefore, I'm sorry. Integrated multi-trophic aquaculture is based on the ecosystem carrying capacity of an area. We need to increasing the total biomass from this area. If we are combining and culture species from the different trophic level, from different feeding habit, are cultivated in the way that producing more food from this area, in which the byproduct, the waste from one species, here is tilapia, are recycling to become food and input for the another species to create a balanced system of environmentally sustainability and increase income while ensuring generated nutrient by recycling nutrient. In this system, once the fish feed is added to the system for the tilapia, part of this food used for the growth and the metabolism, and the remaining part excretion as soluble as solid faces. Unfeed faces and soluble excretion are recaptured by different aquatic animal is different from the feeding habit, including benzodiazepines, filter feeder, micro phytoplankton feeders such as silver carp. Extractive species use the organic particular nutrient for nourishment, acting as a living filter. Once the end of this system of aquatic system, the remaining is the soluble nutrients such as nitrogen and phosphorus. So we are used biological filter using nitrosomonas and azotobacter for the bacteria to convert this source, this form from the nitrogen and source, this is a toxic for plant, to the available source and can be used for the plant. So nitrogen converted from the NH3, NO2 to NS3, and phosphorus. This nitrate and also phosphate are absorbed by plant root and cleaning the water for the fish. And in this point, we can recycling the water for that. This is the basic for the system. We are used solar energy as a source of energy. We are used greenhouse, 3 greenhouse, as we can see from this picture. This is the first greenhouse to cultivate the different aquatic trophic level of aquatic animal, and this for traditional culture to comparison purpose, and this the third one from the greenhouse to using hydroponic system, nutrient film technique, and raft system. Also, we are used to regulated monitoring of water and environment condition. We are used IoT system. We're using 11 sensor to measure of water pH, dissolved oxygen, EC, temperature, and TDS. Also, we are using offline sensors to determine soil moisture, soil pH, and light intensity. Some analysis for the water quality were made weekly and bi-weekly and monthly for cation and anion, and also to trace element to sure of the good quality for the system. Also, we are produce HortiMed field book, this including the all data, and give the end user module for the operation and smart monitoring of water, production of crop and pest management solution for this. Also, we have mobile application and web application to control the temperature at 30 minutes. For the result, we are, if we are considered the first bond as monoculture, we are increase the total production of this system. We are increase and double production. We are increased from 126 kilogram to 236 kilogram. Also, the total production of plant from this production was reach about 780 kilogram. For total production of aquatic animal and plant was reach 1 ton per this area, compared to 126 kilogram. Also, we are increase water use efficiency, we are increase the nutrient use efficiency, and we are decreasing the feed conversion ratio for all system by including the cumulative feed conversion ratio for the system. Especially, the Nile tilapia is only species fed. Therefore, we are increasing the feed conversion ratio from 2.4 kilogram per 1 kilo to 1.4 to 1.5 kilogram per 1 kilo. And the next cycle production, we will reach this value to less than 1. This is very important, because the feed conversion ratio is the source for the CO2 emission. Therefore, IMTA aquaponics as a bio-integrated food production is not only a successful method for the stimulate crop and aquatic biomass production, but also a suitable strategy for recycling nutrient, water, and adaptation to the climatic change. The lack of global model that can take into account direct and indirect effect of climatic change and aquaculture make it difficult to estimate the effect of climatic change. To overcome this, we need a strategy to including the following: determining the impact of climatic change on aquaculture production and sustainability implication by highlight how each specific component of the climate change affects the aquaculture sector, presenting some mitigation and adaptation options that may have broader application as well as challenge for the successful adaptation. Then it concluded with proposal for future development perspective for the aquaculture production. This some picture from our production and system, and also this including the real picture for system and my team. Thank you for my team. At last slide, I need to introduce also the rice production as another production for to adaptation for the aquaculture production. This growing rice with fish with different system, and option 2 climatic change. And I will show, as if we have time, 1 minute video for the production.
Thank you, Prof. You can go ahead and share the video. If it gives you an option to share your computer's sound, sometimes the sound on the video is poor, but let's go ahead and try.
Okay. Okay, thank you very much, Etienne. Okay, Etienne, thank you very much.
Thank you, Professor.